Welcome to the world of Python programming, where decision-making reigns supreme. In this comprehensive guide, we'll unravel the intricacies of conditionals and logic, empowering you to write intelligent and responsive programs. Prepare to embark on an exciting journey into the heart of control flow, the backbone of dynamic software. Get ready to master the art of guiding your programs through intricate decision-making processes. By the end of this essay, you'll wield the power to create programs that adapt, respond, and make intelligent choices based on the data they encounter. Let's begin. Imagine a world without choices, a rigid path with no deviations. That's what programming would be like without conditionals. Conditionals are the decision makers of your code. They empower your programs to respond differently based on varying conditions, just like we humans make choices based on the situations we encounter. Without conditionals, programs would be limited to executing the same set of instructions regardless of the input or circumstances. Conditionals introduce flexibility and intelligence, allowing your code to adapt and react dynamically. This dynamic behavior is what makes programs truly powerful and versatile. The if statement is your gateway to conditional execution. It's like a gatekeeper that evaluates a given condition. If the condition holds true, the code block associated with the if statement is executed. If not, the program gracefully bypasses that block and moves on. In this example, the if statement checks if the temperature variable is greater than 30. If it is, the message, "It's a hot day, time for ice cream," is printed. Otherwise, nothing happens. The if statement empowers your code to respond selectively based on specific criteria. The else statement acts as a perfect companion to the if statement. It provides an alternative path for your program to take when the if condition turns out to be false. Think of it as a safety net, ensuring that your code always has a designated route to follow. Now our code handles both scenarios elegantly. If the temperature is above 30, we get our ice cream message. If not, we're advised to enjoy a walk. The else statement guarantees that our program provides a suitable output for all possible temperature values. Section 5. The If-Elif statement navigating multiple conditions. When faced with more than two possible scenarios, the If-Elif statement comes to the rescue. It allows your program to make decisions based on multiple conditions, ensuring that the right block of code is executed for the right situation. It stands for else if and allows you to test multiple conditions sequentially. This means you can check for one condition, and if it's not met, move on to the next, and so on. Your program will gracefully traverse through these conditions, executing the code block associated with the first true condition it encounters. This makes your code more efficient and easier to read. Let's look at an example. Imagine you have a variable called temperature set to 15. You want to categorize the weather based on this temperature. Python temperature equals $15 if temperature 30. Print, "It's a hot day, time for ice cream." Elif temperature 20. Print, "The weather is pleasant, enjoy a walk." Else print, "It's a bit chilly, grab a jacket." This way, your program can handle different temperature ranges and provide appropriate messages. In this enhanced code, we've introduced an elif statement to handle a new temperature range. This makes the program more flexible and adaptable to various conditions. The program now categorizes the weather into three distinct categories: hot, pleasant, and chilly. This categorization helps in making the program's output more user-friendly and relevant. The If-Elif statement provides a structured way to handle a series of alternative conditions. By using If-Elif, you can create more complex decision-making processes in your programs, making them smarter and more efficient. Section 6. Nested conditionals. Delving into complex logic. For intricate decision-making processes, Python allows you to nest conditionals within one another. This technique is essential when you need to evaluate multiple criteria before arriving at a decision. This means you can have if, elif, and else statements residing within other if, elif, or else blocks. By doing so, you can create complex logical structures that can handle a variety of scenarios. Nested conditionals are particularly useful when dealing with multiple layers of conditions. For instance, consider the following Python code. Is underscore weekend equal sign true, is underscore sunny equal sign false. If it's the weekend, we then check if it's sunny. If it is sunny, we print perfect day for a picnic. This allows us to make decisions based on multiple factors. If it is not sunny, we print maybe catch a movie indoors. This way, we can handle different outcomes based on the weather. If it is not the weekend, we print time to focus on work or studies. This demonstrates how nested conditionals can help us manage various scenarios efficiently. In this example, we determine the ideal activity based on whether it's a weekend and if the weather is sunny. This layered approach ensures that all conditions are evaluated in a logical sequence. The nested if statements create a hierarchical decision-making structure, allowing us to handle 4 distinct possibilities based on the combination of these conditions. This method is powerful for creating robust and flexible code that can adapt to various situations. Section 7. Comparison operators, the building blocks of conditions. Comparison operators lie at the heart of conditionals, allowing you to compare values and determine the truth of conditions. They are fundamental in programming, enabling decision-making processes that drive the flow of your code. Python offers a rich set of comparison operators to cover a wide range of scenarios. These operators are versatile and can be used in numerous contexts, from simple checks to complex logical expressions. Let's explore some of the most commonly used ones. Equals. Checks if 2 values are equal. This is often used to verify if a variable holds a specific value. Not equals. Checks if 2 values are not equal. This is useful for ensuring that a value does not match a certain condition. Greater than. Checks if one value is greater than another. This operator is frequently used in loops and conditional statements to control the flow based on numerical comparisons. Less than. Checks if one value is less than another. Similar to the greater than operator, it helps in making decisions based on numerical thresholds. Greater than or equals. Checks if one value is greater than or equal to another. This is particularly useful in scenarios where you need to include boundary values in your conditions. Less than or equals. Checks if one value is less than or equal to another. It ensures that the condition holds true even at the lower boundary. These operators are essential for constructing meaningful conditions in your if, elif, and else statements. They allow your code to make decisions and execute different branches based on the outcomes of these comparisons. They empower you to compare variables, literals, and expressions, making your code adaptable and responsive to varying data. By leveraging these operators, you can create dynamic and flexible programs that react intelligently to different inputs and conditions. Understanding and effectively using comparison operators is a crucial skill for any programmer. It not only enhances the functionality of your code, but also improves its readability and maintainability. So take the time to master these building blocks of conditions, and you'll be well on your way to writing more robust and efficient Python programs. Section 8. Boolean Logic, combining and modifying conditions. Boolean logic plays a crucial role in shaping the flow of your programs by allowing you to combine and modify conditions using logical operators. These operators provide immense flexibility in constructing complex conditions. For instance, you can check if the temperature is within a specific range using, or determine if a user's input is valid by combining multiple checks with. Section 9. Truthy and Falsy values. Understanding Python's perspective. In the realm of Python, the concept of truth extends beyond simple and. Python embraces the notion of truthiness and falsiness, where certain values are inherently considered or in a Boolean context. Truthy values, non-empty strings, non-zero numbers, and non-empty data structures, lists, dictionaries, etc., are generally considered truthy. Falsy values, empty strings, zero, none, false, 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 true, false, in many cases. Section 10. Python's evaluation process, unveiling the order of operations. Python meticulously follows a predefined order of operations when evaluating expressions, ensuring consistency and predictability in code execution. Parentheses take precedence, followed by exponentiation, then multiplication and division from left to right, and finally addition and subtraction from left to right. For example, consider the expression result equals 10 plus 5 times 2 minus 8 divided by 2. In this example, Python first evaluates the expression within the parentheses, 8 divided by 2 equals 4. Then it performs multiplication, 5 times 2 equals 10, followed by addition, 10 plus 10 equals 20, and finally subtraction, 20 minus 4 equals 16. Understanding operator precedence is essential to ensure your expressions are evaluated as intended. Section 11. Conclusion: Mastering Control Flow for Effective Programming. Congratulations! You've embarked on a journey through the captivating world of conditionals and logic in Python. You've learned how if, else, and elif statements empower your programs to make decisions, and how comparison operators and Boolean logic provide the building blocks for intricate conditions. As you continue your Python adventures, remember that mastering control flow is fundamental to writing efficient, adaptable, and intelligent programs. Embrace the power of conditionals, experiment with different logical constructs, and let your code come alive with the ability to make smart choices. Happy coding!